Hey guys, this is Jom and welcome to Civil Raja, your gateway to future. So guys, today we are going to continue with our series on how to study the structural drawing, and I am just going to share my screen with you. So yeah, here is my screen, and now you can see we have already completed 4 episodes in this where we have discussed the importance of the structural drawing. Then we have covered what's inside the structural drawing and how we have to read the different details like what is there general details in the drawing. Then we have learned about how to study the pile cap details, and finally you have learned how to study the pile details in episode 4. So today is episode 5 and we are going to continue with the series. Okay, so I'm just going to study the plinth beam drawing today. Okay, so you can see over here we have our plinth beam details, and I'm just going to start with the plinth beam schedule over here. So the table that you see in the structural drawing is the plinth beam schedule, and here we have used two types of the plinth beams. One is PB1, second is PB2. Okay, so before discussing why there are only two types, like the whole table, let's understand why there are only two types of the plinth beams. Okay, because whenever we are designing something in the like STAAD Pro or any other software like Tekla Structural Designer, we will see that all the beams are having different dimensions, and that will lead us to different types of the plinth beams. At least 7 to 8 types of the plinth beams should be there. Okay, but when we have to work on the side, then you will see that we do not go for the casting of every individual beam at once. Okay, so how we do it? We cast the beams in the whole axis. Okay, so what is the axis? Let me show you. So over here you can see this is the complete axis. Okay, so this is axis 1, this is axis 2, this is 3, this is 4, this is 5, and in the vertical direction we have A, B, C, D, and so on. Okay, so there are different axes over there. Okay, and we have to mark it along that. Okay, so I will just mark it over here. Okay, let's start with this one. So you can see this is one axis, this is second axis. Okay, and if you will just go for this direction, okay, then you will see that this is one type of axis, then we have this is another type of axis. Okay, and here we have another type of axis. Okay, so when we are working on any particular axis, so then we can just go with that particular beam over here. Now you will see that in this axis, that is axis 1. Okay, and every axis is having a particular name over here. Okay, so you can see in axis 1 we have PB1. Okay, so you can see the whole axis is PB1. Similarly, when we have to talk about axis 2, then you can see we have PB2 in the whole axis. PB2, PB2, here PB2, again PB2, PB2. Okay, so whenever we have to provide the details, we do not simply copy it from the STAAD Pro or the Tekla Structural Designer. We just categorize every beam into such an axis. Okay, so suppose if you are using the RCDC software, then it will automatically just arrange it, okay, according to the axis. But normally when we are working on the STAAD Pro, I haven't used ETABS much, so I don't remember that much. But STAAD Pro and Tekla Structural Designer, in these two softwares, we will not find any categorization of the axis. So we have to categorize it. Okay, so that can be done manually. And now from the aspect of reading the structural drawing, you can see that we have different like axis for particular type of the beams. So in this drawing, we have two types of the beam over here, PB1 and PB2. So let's study the details of that. And for that, we have this schedule. So in this schedule, we have all the information related to the these two beams that is being used in this project. So first is the PB1, which is having the size of 250 by 350, and then there are bars. So you can see we have 4 bars in total. Okay, so the top 2 bars are of 25 dia, and the bottom 2 bars are of 25 dia. There is no extra reinforcement, so these bars will be the continuous bar, and there will be no kind discontinuity in this particular beam. However, if you will go for the more complex structures, so then you will see that there can be some extra beams in the plinth beam also. Like in our project, we will see that in the roof beam category. Okay, so I will show that in another episode. First of all, let's understand this one. Then we have the some shear reinforcement, which we will also call as in columns it is known as ties, and in beams it is known as stirrups. Okay, so shear reinforcement is basically the stirrups. So these are the bars that tie, okay, all the reinforcement that is being provided in the beam. Okay, so here we are using 8 dia bar, and these stirrups are placed at a spacing of 125 at supports and 150 at center. Okay, so now there may be another question like what is the distance of the support and what is the distance of the like center. Okay, so like which portion can be called as support and which portion can be called as center. Okay, so there may be a question. So for that we are basically using a formula that is L/6 over here. So uh in this particular structural drawing, we have another sheet where we have marked it. Okay, so you can see in the supports, it is termed as ST1, and in the center, it is termed as ST2, right? So you can see the ST1 for this PB1 section, and for axis 1, we have different distances over here. So from support to support, that means column to column, we will consider it as a single beam, then another column to column, and another column to column. Okay, so this support can be of like secondary beam also, or you can say there can be a primary beam as a support also, but over here we are having this as a column. Okay, so in this particular section, let me see if we have any other support other than the column. Okay, so that is possible. Yeah, over here you can see we have PB2 as a support. Okay, so it's not necessary that only the columns will be considered as a support. Even beams can be considered as a support. That is my only point of explaining this. Okay, so over here you can see we have our two like different zones, that is ST1 and ST2. Now ST1 will be there in the supports, ST2 will be there in the like center. Okay, now let's look at the arrangement. So you can see this is the whole diagram over here, and you can see this will show you where we have which type of beam being used. Now the question is what is the reinforcement that is being used in the beam? So we do not need to study everything individually. Yeah, if there will be something special over here, then I will definitely mark it. Otherwise, let's study a single axis, okay, of each type. So you can see I will study this one, that is axis 1. Okay, so in the axis 1, I hope now you are clear that why we are using the single type of beams over here, because it is easier to cast and that is also a safe option. Okay, and we do not have to use the different sizes of the formworks over there. We can just go with the like same type of formwork in a particular axis, and that will lead to the safer construction. Okay, so that's why we have to use this. Okay, now I'm just going to study this whole thing. So first is thing is that we have to consider the supports and the distances between the supports. So the distances between the supports can be like seen from here, and well, we will just mark the column positioning, then you will know that the columns are already constructed over here, and now we have to construct the beams. Okay, so here we have the center to center distance that you can get from this one. Okay, and for each axis distance is given over here. Okay, so whatever axis is being used, the center to center distance is already provided. Okay, now if you have watched my video on column, okay, I guess I haven't studied the column yet, but do not worry, I will just study it in a different video. Okay, now let's come over here. Yeah, so we have this column and column. Okay, so there are two columns over here. In between these two columns, we have constructed a PB1 beam that is having the dimension of 250 by 350. So it is very convenient if it is marked like this. We do not have to check the particular schedule every now and then, because it is clearly marked over here as 250 by 350, which is the genuine size of the beam. Then the top reinforcement and the bottom reinforcement are two bars of 25 dia. Okay, so that is what is marked over here. So 225 all through means it is starting from one point and it will go continuous till the support. Okay, then again we have the 225 all through. Now this is another benefit if you are using the same kind of beam over here. Okay, suppose you are using a PB2 over here that may have a different set of bars, that may be two bars of 20 dia, then we will have to lap and do all these things. Okay, but if you are using the same kind of beam, then we can simply continue the beam. And you know that whenever we are like purchasing a like reinforcement, then that is of almost to a 12 feet, right? So the continuous beam as a continuous rod without any lapping or weld is much stronger. Okay, right? So here we are using a all through bar. Now you can see we have this development length that is being provided over here. Okay, so what we have to do, we have to provide the development length. So from here, that is the edge of the column, we have to start the development length. So how much it will go? So in this direction, it will go like anywhere, like leaving the clear cover. Okay, so this distance will be the thickness of the column minus 40. Okay, because 40 is the cover that is being provided to the columns in this particular project. Normally the cover of the column is 40 Okay. Now from here to here, it will be a thickness of sorry, the width of the column minus 40. Then we have to extend it down. Okay, so how much we have to extend it? So this plus this length should be 50D. So in our case, we are using a 25 dia rod. So the development length in our case will be 25 into 50. Okay, which is 1250. Okay, so suppose the column is of 350. So that will be minus 350 over here. So 900 we have to go down in this column. Okay, now when you have to provide some beam, then we will not go that much. Wherever we have to just go with the beam, we will simply use the development length till its depth. Okay, or we can simply bend it in case required. Okay, so that is the case over here. Then what we have to do? Okay, yeah, say next thing that we have to learn over here is this ST1. So that is the zone which is at the supports. So over here we have a support, so that is ST1. Even in this side we have a support, so that will be ST1. Okay, and the distance is different for each beam. Okay, so for every support to support, we have to consider the length of the beam. So whatever is the length of the beam that we can get from this particular diagram, okay, where the beams are marked. Okay, so this length will be 2875 plus 1925 minus the like addition of the columns. Okay, so I will just show you how much it is. 2875 plus how much? 1925. Okay, minus, I guess in this case it is 350. So 4450, that is the length of this particular beam. So in 4450, what we have to use? We have to use 1200 from this direction and 1200 from this direction as zone ST1, which is the zone considered for the supports. And whatever is left in between, that will be considered as ST2. And why these zones are important? Because here you can see in the shear reinforcement, we have different spacing for the beams. So for the stirrups, okay, so stirrups are being used of same type, that is 8 dia bars, but the spacing over here is different. For the supports, it is 125 center to center distance. Sorry. Actually, I was suffering from flu, and that's why this video is getting so late. Okay, and I have not recovered completely, but I'm much better now, and I guess I am good enough to just record this whole session. So guys, that was the reason why I haven't posted any kind of video lately. Okay, now you can see over here we have this center. So the center portion is having a different spacing, that is 150 center to center, and the dia of the bar is dia of the stirrups is 8 Okay, now in the same manner we have to just provide the spacing for each particular beam. Okay, However, in a single axis, we will use a single type of beam. Okay. Now let's see if you have any other condition. So all the conditions are being supported. Okay. Yeah. One more thing. Suppose the like this beam has to continue like this. Okay. So over here in this support, we will not provide any development length like we have provided over here in axis 1A. Okay. So over here, this bar will continue. And if this bar is like ended because of any reason, then we can just go for the lap. Okay. So lapping, we can provide as, I guess, let me just calculate it again. 45 into. Okay, so for the lab, we will just go for the general nodes. Okay, let's see if it is mentioned over here. Otherwise, I will tell you the formula for that. We have to go for 3 different aspects which we can see from, yeah, which we can see from the like IS code. Okay, now you can see development length provided over here is 50 into die of the bar. Okay, then for the labs, normally we use the 300 mm, or we use a formula. Okay, let's see the formula. Okay, and that is not mentioned over here in the general note section. That is usually mentioned, so I will simply mention it, and I will tell you about that in the upcoming video. However, that is 45D. Okay, so whichever is more, we will simply use that. Okay, now, yeah, so we have to simply continue this main bar from here. I hope everything is clear in this case. Now let's go for plinth beam. Okay. Yeah, supports wherever the beams are used as the supports. So if this depth is lesser than what is being provided as the development length, then what we can do, we can simply just bend it like this. Okay, so that is another case what we can do. Or for the ease of the construction, sometimes the people also leave it till here. Okay, so both the cases are correct. That is not an issue. Okay, because that will not affect very much in such cases. Okay, so I guess there is no more extra point in the study of the plinth beams. If you have any kind of question, then you can simply just leave that in the comment section. I will definitely answer that, because my voice is a little bit not in a good condition, but obviously my hands are. So I will definitely reply every question in the comment section. So do ask your questions, and in the next video, I will discuss either the roof beam, because we have much more details in the roof beam than the plinth beam section, and or I will just start with the column portion. Okay, so I guess that is all for today. We will meet in the next session. Till then, take care. Bye-bye. And please like this video, share it with your friends and colleagues, and subscribe to our channel if you are new to the channel and haven't subscribed it. Thank you, guys.